This is the solution for station number 3. I can name binary ionic compounds that contain transition metals. More specifically, cations with multiple charges. If you'd like, you may pause this video so that you can check your answers before continuing with this video, which will attempt to explain the individual answers. Whenever you're given a formula, you need to look and see how many different types of elements are within the formula. If you have 2 types, that is called binary compounds. All binary compounds end in IDE or IDE. In addition, when you have 2 elements, if the first element is a metal and the second one is non-metal, we consider them to be ionic. So in this case, these are all examples of binary ionic compounds because the first elements are metals and the second elements that follow are non-metals. In addition to station number 3 versus station number 2, the metals here have multiple charges. Not all, but most. Whenever you have multiple charges, we are to note their charges in the name so that when you do write formulas from the name, you can properly note their charge and note the amount that you need. To find out what charges they are, we must look at the anion. The anion charges are designated. Because they are designated or constant, we can use that information to determine what the cation charges are. For instance, bromine here is a group 7A, which means that it is -1 by itself. Because we have 2 of them, that would mean that there's a total on the anion portion of -2 charge. Looking at mercury, seeing that I only have 1 mercury here, that would indicate that mercury here, to balance out the total of -2, must be +2 of itself. That tells me that mercury, having +2, must have Roman numeral 2 in its name so that we can indicate its charge. So name will be mercury . Okay, parentheses now, 2 for the 2 charge, and then bromine, instead of being bromine as we've indicated, it will lose its suffix and then become IDE in its ending, making this bromide. Okay, so that would be mercury 2 bromide. Looking at the next compound, in this case copper and phosphorus, copper, just like mercury, has multiple charges. To find out what that multiple charge is, just like in the first example, we will have to look at the anion. Phosphorus is group 5A, indicating that each of the phosphorus carries a charge of -3. If that is so, then copper in total must add up to +3. Seeing that copper has 3 in its quantity, that would mean that each of the copper has to be +1 to make the total charge become +3, which will add with -3 to make it 0. The net charge is the 0 that we want. So the name here will be copper. However, because it has the charge of 1, we will use Roman numeral 1 to indicate that charge, and afterwards we'll follow up with the anion with the IDE ending as a binary compound, so it will be phosphide. Okay, so that's copper 1 phosphide. Next substance, cobalt and oxygen. Cobalt also has multiple charge. Oxygen is a group 6A. Oxygen has -2 charge, and because there are 3 in total, that would mean that total charge that the anion is producing is -6. That would mean that the cobalt as a total has to be +6. Seeing that we have 2 of cobalt, individual must be +3 so that you can achieve +6 charge. So cobalt will get its name, and just like before, those with multiple charges will get parentheses indicating the charge of the cation, in this case 3, with the name of oxide because of the fact that it is a binary, and binaries all end in IDE. Moving along with the next example will be magnesium with selenide or selenium. Manganese also has multiple charge. Selenium is group 6. It has -2 charge. Now, because manganese only has 1 as its ratio number, subscript, that would mean that individual manganese has to be of +2. So manganese, with its name written, will have in its parentheses Roman numeral 2 to indicate the charge of +2. And the name here, selenide, is the resulting name because it is, again, a binary ionic compound. The next substance here is gallium with arsenic. Gallium and sodium, they are both those that only have one designated charge. And if you have one designated charge, there is no need for Roman numerals. So unlike the other ones that you see here, gallium is going to not have any of the Roman numeral indication because it has only one designated charge. Arsenic will follow along suit with others that you see of binary compounds, which means that it will end in IDE. So this would be arsenide. Okay. As I mentioned, sodium 2, group 1A, it is not multiple charge, one designated charge. It does not require a Roman numeral, so this will be sodium bromide. Okay, now we come to iron. Iron has multiple charges, +2 or +3. In order to determine which of those two charges are, I look at my anion. Phosphorus, as we have mentioned before, is of -3 in charge. If phosphorus is -3 individually and I have a total of 2, that would mean that the anion portion has a total of -6, which means that the Fe, 3 of them, has to add up to a total of +6. To make that happen, each iron has to be 2. 2 times 3 giving you +6. So it will be iron with the Roman numeral 2 for the 2 charge that it has, with the name phosphide as a binary ionic compound. Okay, now we come to the last substance. The last substance we have is lead. Lead, just like iron and other multiple charge cations, has, in this case, a charge. So we'll look at the anion, the nonmetal, nitrogen, which is in group 5A, and 5A's all have -3 charge on it. There is a 2 to indicate there are a total of 2 nitrides, making this of -6 in total, which means that Pb, lead, has to have a total charge of +6 to balance out the charge. I see that there are 3 lead ions, which means that individually it has to be +2 to make the total charge of +6. So lead, name in this case, has a Roman numeral of 2 to indicate +2 charge, and it will be lead 2. Nitrogen will then, just like others in binary compounds, as a anion or nonmetal, it will be nitride. Okay, so a slight bit of mistake. We'll scratch that out and write the word nitride. Okay, that concludes station number 3. If you have any questions, please raise your hand for further instructions.